All right, so this is the lesson 11 homework. It's page 157 and then 158. Okay, so I'm going to do some on this side and some on the back. So let's look at problem C because that one looks like one of the harder ones. So it says solve using standard algorithm. So let's set this up. All right, so first let's estimate so we can figure out where the decimal point should go. So we have 371 is about 370, which is about 400. So we have about 400 times 50 if we estimate. 20 plus 3 more zeros. Oh, while we're at this conversation, I've seen kids set this up like this. And then they end up getting really confused about all the zeros, and sometimes kids end up with the wrong amount of zeros. So if you do these sideways, it's really pretty easy. 5 times 4 is 20 plus 1, 2, 3 more zeros. So that makes it harder, I think. I've seen a lot of kids make mistakes when they do it that way. All right, so solve row 1. All right. And then add in the 0 because you're doing times 50, so we need to shift. 11. 5 times 1 plus 1. 35. All right, really important we line all these up. All right, so that's a really big number. And I need to figure out where the decimal point goes. So I need something worth about 20,000. So I need 1, 2, 3, 4, 5 digits on the left side of my decimal point because the decimal point would go right there. 1, 2, 3, 4, 5 places on the left. So that was one way to think about it, was I needed 5 places. It should go to the 10,000s, to the left of the decimal. If you think about it, 19,675 would round up to 20,000. Another way to think about it is you had your 3 ones times your 3 hundredths is 9 hundredths. 1 times hundredths makes hundredths. That means this column is your hundredths. Hundredths, tenths, decimal point, ones. Okay, so let's go ahead and let's do another one on here. So let's go ahead and do B. So first let's estimate 53 and 16 hundredths is about 53, or about 50, times about 30. Five times 3 plus the 2 zeros. So I should get about that when I'm done. $21. Add your 0 for the times 30. All right, now I want you to pretend that you have a neighbor in class to talk to right now. How could you explain to your neighbor, how do we figure out where to put the decimal point? Because we know the answer is not 180,744. We need to have a decimal point in here to separate the whole numbers from the decimals. All right, so one way to think about it is you need about 1,500. So the decimal point would be here. You would need 1, 2, 3, 4 places on the left of the decimal. 1, 2, 3, 4 goes into the thousands. 1,800 is pretty close to 1,500. Another way to think about it would be you have 4 ones times 6 hundredths. 4 times 6 hundredths was 24 hundredths. Ones times hundredths makes hundredths, which means this 4 is in the hundredths, so this row or column is our hundredths. Hundredths, tenths, ones. All right. Okay, so read those directions. So they've got us thinking about this another way, and they gave us the numbers that we need. So these problems are the same, except that one has a decimal point. So the numbers are the same answer. But they need to put in a decimal point, so let's think. This one has a decimal point 2 over. So then this one should have a decimal point that's also 2 over. So that's one way to think about it. Also, I can think I have 36 times 1 is 36. So my answer should have tens and ones. Okay, let's try the next one. These are the numbers in my answer. But I know it's not 224,000 because that doesn't make sense. So this one has decimal 2 over. So this one will have a decimal 2 over. 80 times about 26 is about 30. +24 plus 2 zeros, so I need something worth 2,000 something. 2,246. 2,400, those are pretty close. You can also think how these are hundredths, so my answer will end in the hundredths. Hundredths, tenths, decimal point, ones. Try C on your own, and then we're going to do the story problems. So this should be my tenths. So I should have my tenths in my answer. And then I used whole numbers to kind of think if it made sense. I should get about 6,000. So the decimal point needs to go there to have 6,000 something. All right. Okay, so try number 4 on your own and then check back. All right, so let's figure out where the decimal point should go. Well, I can think of it a few ways. I have $1 times 27 would be $27. So it needs to be something with tens and ones. Another way to think about it is $1.57 would round up to $2. And 27's about 30. So 30 times 2 is about 60. So I need to put the decimal point so it's worth about 60. Somewhere between 30 and 60. Oh, that'd be right there at $42. Or I can think these are my hundredths. 7 ones times 7 hundredths would be 49 hundredths. Those are the hundredths. Hundredths are your pennies. All right, go to number 5. So a whole spool of ribbon is 6 75/100 meters. They're going to buy 21 spools. The cost is $2 per meter. So let's go ahead and write out what we need to do to solve this. Well, we need to take the 6 7/75 meters times the 21 spools. Like spools are like spools of thread, so spools of ribbon. And then if we get that, then we can multiply that times $2 for every meter. So we need that amount times $2 to get the total cost. So read that problem again and think about why this makes sense. And then we could put parentheses if we want to think about how we could do that first and then do that times 2. Alright, so go ahead and work on that. So these are my hundredths, tenths, and then ones. So there's my change and there's my whole numbers. I also thought about, well, 6 times 20, 6 ones times 20, or 6 whole meters times 20 would be 120. Or if we rounded 6.75, it would round up to 7. So 20 times 7 would be 140. So it should be somewhere around there. Then we need to do that times 2 to get the amount of dollars. So these are my cents. So it'd be $283.50. And think if that makes sense. You have 141s times 2. About $140. Or $140 times 2. Dollars per meter. Too much math today, Miss Fryer. Should be about $280. Whew. Alright, I'm tired, so I'm going to give you a choice. Actually, no. Let's do this last one because it's got something different in it. Alright, read the next one. Okay, so let's do a tape diagram. We want to know how much is left. So guess what I just realized because I was rushing, and this is why we don't want to rush. This amount is meters, and I did not label that. So when I was done, I came up with this and I put $sign like it was money. But this is your meters times 21 spools should tell you how many meters of ribbon you have. So actually, that should not be money. I knew that didn't feel quite right. Something felt kind of weird about that. So those are my meters. Times $2 gave me my dollars. Alright, so if they use this much of it, we want to know how much is left, so we need to subtract. But let's make a tape diagram because I've noticed we're not really sure about subtraction tape diagrams. So our bigger number on our tape diagram, the meters that we have, is going to go at the top. Part plus part equals whole. So if I take the total and I subtract out the other part I know, the part we used, that is what's left. So that's the math we need to do. Okay, so try that on your own and check back. And how could I check to make sure my regrouping is right? I should add these back together. Okay, so that's what I'm going to do right now to see if I'm right. Thanks. Oh, I forgot my sentence. How much will be left? The club will have this many meters of ribbon left. Okay, so that's kind of messy for a sentence, but I'm trying to save us some time. Okay, have a good night.